Dear friends, today we will discuss the bond energies, that is bond enthalpies, and also called as the bond dissociation enthalpies. Suppose we have the molecules of hydrogens. Okay, number of molecules hydrogens is there. 1 mole of hydrogens molecules is there. Okay, that is the quantity of 1 mole is the weight of one hydrogen is 1 plus 1 is equal to 2 gram gaseous forms of hydrogens are there. Now these gaseous forms molecules, the energy required for break of 1 mole of gaseous molecule into its gaseous ion is called as bond energy. Okay, the energy is taken by these hydrogen molecules and it gets breaks, and then it will use its gaseous ions. Okay, number of gaseous ions obtains due to breaking of hydrogen bonds. The energy is gained by these gaseous forms of molecules for breaking of 1 mole of compounds into its gaseous form. This energy is called as the bond energy. Okay. Now, for different molecules, this bond energy is different. Suppose for hydrogen, the average bond energy will be the 435 kilojoule per mole. For bromine molecule, Br2 molecule, the bond energy is the 190 kilojoule per mole. Okay, that is the average bond. These quantities are the average bond energy. Other way we can define bond energies or bond enthalpies or bond dissociation enthalpies or bond dissociation energy, like the 1 mole of gaseous ions it gives the energy for the formation of 1 mole of its molecule. The energy exhausted by these gaseous ions for the formation of 1 mole of H2 molecule is also nothing but the bond energy. Okay, these are the two opposite things. Therefore, in first case, for the breaking of the bonds, you will require the energy, then it is converted into its gaseous ions. The energy is required for breaking of these molecules. Okay, how many quantity? 1 mole quantity to converts into its gaseous ions, and other way we define the 1 mole of gaseous ions. The energy is produced for the formation of its molecule is nothing but the also the bond dissociation enthalpies or bond energy. One gives the energy and one take the energy. Okay, for the breaking, you should require, for breaking the bond, you should require the energy. Therefore, the bond, all these three definition as the bond, the word is there. The energy required on the breaking of bonds of one mole molecule into its 1 molar gaseous science is nothing but the bond energy. It is related to the bond, breaking of bond. Okay, previously we discussed that these are the average bond energies for different molecules or different what we call, where there is the H2O, which is a polyatomic molecule. H2 is a diatomic molecule. In H2O there are 2 bonds. In H2 there are only 1 bonds. Therefore, the energy required for the H2 molecule or diatomic molecules is nothing but its bond energy. But in case of polyatomic molecules, the energy required for same types of bonds is not same. For the breaking of same types of bonds in a molecule may require different energy. Suppose we have polyatomic molecules, that is water. Polyatomic molecules means what? More than 2 atoms is there. H2 is your diatomic molecule. Okay, di means the 2 first and second hydrogen, and water is a polyatomic molecule. Okay, first, second and third, more than 2 atoms is there and more than 1 bond is there. If you take the 1 mole of hydrogen and break it, you will obtain the energy, that is the 436 kilojoule per mole. Okay, 1 mole of when you breaks, there is no what you call it, is directly that energy is its bond dissociation energy. For polyatomic molecules, we might be thought that the energy of breaking of OH and energy breaking of second OH can be same, but actually in polyatomic molecules, whether it has same types of bonds, in water OH first bond and in OH is the second bond, both are the same types of bonds. But for breaking of these bonds, bond number 1, bond number 2, there are different energies required. Therefore, for the calculation of the bond energy of water molecule, we have to take average of both the energy required for breaking of these OH bonds. Suppose for first bond water is there, and for the first bond, for the breaking of this molecule, first breaking in gaseous form, the energy is required 498 kilojoule per mole. And for the breaking of second OH, the energy is required as is 430 kilojoule per mole. Okay, this bond is breaking. You can see that the bond breaking energy of first OH and second OH is different, not same whether these are the same bonds. Therefore, for the polyatomic molecules, we can take average of the number of bonds energy required for the breaking. In this case, the bond energy will be 498 kilojoule per mole plus 430 upon 2. Okay, it will becomes is equal to okay, then you will obtain the energy is the sum average of these two bond dissociation energy will gives the bond energy, that is the average bond energy for OH in water. Okay, therefore bond energy for a certain bond is nothing but the average of all same kind of bond energies for same bond. We take the average of all these bond energies. Okay, bond energy is nothing but the average of all same kind of bond energies, is nothing but the bond energy. And average bond energy in a molecule is nothing but the average bond energies of the same kinds of bonds. This is nothing but the average bond energy. For a reaction, we have a formula to find out the average bond energy. Suppose a reaction A gives the B, then bond energy for a reaction of a reaction is equal to summation of all bond energies of reactant minus summation of all bond energies of product. By this way, we can calculate bond energy for a reaction. Bond energy for a reaction means what? The bond energy of reactant, summation of bond energy of reactant minus summation of bond energy of product. Suppose we have one reaction. Okay, this we have the reaction H2 gives Br to gas form, H2 is also gas form, is gives the twice HBr, it is also in gas form. The energy is given for, it is an example from the Manali book. The energy is given for H2 is equal to 436 kilojoule per mole. Okay, this is the average bond energy. Okay, this can be different from the breaking of a single bond. Okay, average bond energy is the average of same kinds of bond energies. That is your average bond energy. Okay, this is your average bond energy. Then for Br2 molecule, the bond energy is 192. The same example is given in your book. And for the formation of this, we have the bond energy HBr is given as 364. Therefore, three values we have. For the bond energy for HH is the 436 kilojoule per mole, Br2 192 kilojoule per mole, and also HBr 364 kilojoule per mole. Now, in this reaction, only one H2 bond is breaked. In second reaction, only one Br2 is break, And third reaction, only 2 HBr molecules are formed. Therefore, the energy for 2 is the 2 into 364. Therefore, bond energy for this reaction, we have a formula. That is summation of bond energy of reactant minus summation of bond energies of product. Therefore, for this we have 436 plus 192. Okay, this is summation of first, and these two we can add to each other. Okay, therefore 1 and 2 we added this, minus 2 into 364. These values for is related to the bond energy of product. Therefore, by solving this, the energy is obtained is nothing but the energy of a reaction. Okay, we have discussed the point, the bond energy. Bond energy for a reaction is also calculated, and bond energy for a molecule also calculated, because during the formation of a product from a reactor, there is some bond breaking takes place and some bond making takes place, and then you obtain the product. Therefore, the bond break in reactants, and minus the energy bond breaks in different bond breaks in the products make in the products is also nothing but the your bond dissociation energy for a reaction. Okay, we started from, we have 1 mole of gaseous molecules which gives its gaseous ions 1 mole. The energy is required in this process is nothing but the bond energies, or vice versa. The 1 mole of gaseous ions gives the energy for the formation of its molecule is also nothing but the bond energy. We have that bond energy are the average bond energy. Average bond energy means nothing but the average of same kind of bonds when breaks, the energy is required. We average it, then for 1 mole, then we will obtain the average bond energy. For polyatomic molecules and for the monoatomic molecules, the calculation of bond energy for the diatomic molecules, it's directly when breaks 1 mole molecule, the energy is released, the energy absorbed is directly, we can say that it is a bond energy. But in polyatomic molecules, whether the same bond is there, but energy bond energy we calculate average these bond energies. We take on the H2 molecule. For first OH molecule breaking, you required 498 kilojoule per mole energy, and for the second OH you require the 430 kilojoule per mole energy. And then we add together and divide the number of bonds. Okay, in water there is number of bonds, therefore 2 bond energies required. We add 430 plus 498 divided by 2, you will obtain the bond energy for average bond energy for a polyatomic molecule. Therefore, in polyatomic molecule, for a same kind of bonds, the bond energy are different. We have to make the average bond energy in a polyatomic molecule. This is all about our the bond energy and bond enthalpy. Thank you very much.